Hello all, and today we are going to continue on looking at some stuff in chapter 3, and we're going to talk about the second derivative of a function. Now, the second derivative is a kind of, maybe it sounds a little bit more concerning than it is. The second derivative is just the next derivative. So you take the derivative of the one you just found. So it's noted as, with a derivative sign and another, so we call this f double prime. You can also use the d dx notation, so it's just d2 over d2x with the function in parentheses. And again, it is the derivative of the derivative. So once you have the first function using all the same rules, just do it again. So every single rule still applies to the second derivative. You're just going to start each one fresh. Now, before we do a little bit of algebra, which you all are generally pretty solid on, I do want to do a little review of the graphic importance of some of these derivative ideas. So if we're looking over here, one thing I want you to recall is that whenever you have a local min or max, so like for example right here, that means that the tangent line is horizontal. And what this means here is that f prime is equal to 0. This is going to be really helpful. So that's going to be true at all these points. So the red graph's derivative will be 0 here. The green graph's derivative is 0 here. 0, 0, and 0. This is a really helpful idea here because then when I am asked here, identify which of these is the original function, which is the derivative, and which is the second derivative. What I'm going to do in those cases is look for where a function would be 0. So if I'm looking at the blue function, it only has one 0, and it's right here. Now what that tells me is that red right here, so I can make a note, is that red is the derivative of blue. So blue prime is equal to the red function. Now if I look at a different 0, you might say, okay, but maybe then this could also be true. Well, I know that that's not going to be the case because if I look here, green has a 0. There's no point there. So what this tells me is that green prime is not pictured. If we're using our logic then green is f double prime. Since this one has its derivative, this one has its derivative. Oh, that derivative doesn't exist. So this must be the second derivative. Now we want to just see how red interacts here. So if we focus on the red graph, we can say here's where it's 0, and it then hits right here. So what this tells us is that green is the derivative of red. So for our final answer, the original function, since blue is never anyone's derivative, right? So f then must be the blue graph. F prime must be red, since red is equal to the derivative of blue. And as we already said, f double prime is the green graph. So thinking about all of these derivatives in terms of their graphs is going to be really helpful later on. Now here, number 2 says find the second derivative of f double prime, given f is equal to theta sine theta. So as I said, all the same rules still apply. We're going to start by finding the first derivative. And for this first derivative, we are going to use the product rule, since we have theta times sine. So I'll say f is equal to theta, g is equal to sine theta, f prime is equal to 1, g prime is equal to cosine of theta. So our first step, f prime of theta is equal to 1 times sine, so I'll just write sine, plus theta cosine theta, and that's our first derivative. Now for our next derivative, right, this is what we're asked for here. We have two terms, so I will take them separately. This first is just going to be easy to differentiate. It's going to be cosine of theta for the first term of f double prime. This second one, again, we will need the product rule. We're going to start from scratch. Always start fresh with each derivative. So here we have f is equal to theta, f prime equals 1. G in this case is cosine of theta, so therefore g prime is equal to negative sine theta. Don't forget your negatives. So then using the product rule, we have 1 times cosine theta, which I'll just write as cosine theta, plus the negative, so I'm going to write minus theta sine theta. That would be your second derivative, and that's what we wanted to end up with. I'm just going to do a little simplification here. Cosine plus cosine is 2 cosine theta minus theta sine theta. So just follow the same rules that you would any of the power, product, quotient rules, and do remember to start from scratch each time. So did this product rule, and then that doesn't have anything to do anymore, and we're going to start over again to do the second derivative. If you have questions, please let me know by setting up a meeting on Zoom, going to the comments, or sending me an email. Talk to you later.